In this example, we're going to use Excel to answer the question on this slide, which is how to find the equation for the line of best fit to a data set and how to find the correlation coefficient of that linear regression. So the example we're taking a look at is where we have the variable X, which is the average number of employees in a health insurance plan, and Y is the average administrative cost as a percentage of claims. So we've got two quantitative variables. It's a pretty small data set. And so first thing to notice is that the data here happens to be given in a table where each variable is listed across a row. And when I enter this into Excel, I'm going to want to enter this as data coming down where each variable comes down a separate column. So first I'm going to put the header X in cell A1 and the header Y in the cell B1, and these could be titles if we wanted to be more descriptive. And then for each value of X, I'm going to list that coming down column A. And for each corresponding Y value, I'm going to list those coming down column B. And what's important is that when I enter these values, since it's an ordered pair, that the X value 3 should match its corresponding Y value 40. So these need to match up as they did in the way the table was given to us. Okay, now that we've got the data entered into the spreadsheet, Excel spreadsheet, the rest of this is going to be done by Excel. So I want to insert what is called a scatter plot. So I'm going to select all of the cells from A1 to B6, including these headers, then go over to the Insert toolbar up here, and then choose Insert a Scatter Plot. And so this is the Scatter Plot button over here. And so when I click this, there are various types, and although eventually we're going to fit a line to this, I just want a scatter plot with each of the dots at first. So I'm going to click that button, and Excel is going to create a scatter plot for us, which it's not doing. Okay, here we go. So now we've got our scatter plot, and we could do lots of various formatting things like add titles to the axes and whatnot, but for the purpose here, we just want to focus on how we fit a regression line. So one thing to note is that when I've clicked outside of the scatter plot, I've got certain toolbars up here, and when I click inside the scatter plot, I get a couple of additional ones. In particular, chart design and format tabs appear on the top. And so what I want to do is go to the chart design tab, and again, this isn't going to appear unless we're first clicked on the scatter plot. And then I'm going to insert, add a chart element over here, come down and select a trend line, and I want to select a linear trend line. Now that adds the line over here. And the next thing that we want to do is format this line, because by default I don't see what the equation for that line is. And so in order to get that, what we can do is come over and click on the bottom and go to more trend line options. So again, I found that by being on chart design, coming over to trend line, and then coming down to the bottom and choosing more trend line options. And now I get a formatting menu on the right side over here. And depending on which clicked on, I could do formatting, like to change the color and make that a solid line. But what I'm interested in doing now is seeing the equation for the line. So if I click on the three bars over here, way at the bottom, there are options to display the equation on the chart. And once I click that, I can see the formula, and I can click to see the R squared value as well. And now I can see those appear on the chart. So what we can see is that the formula is y is equal to minus 0.28 0.41x, that's the slope. And if it's hard to read, we could drag that around and see that the y-intercept is 37.358. And we have an r-squared value, which is 0.9143. And so notice here, this is not the correlation coefficient. It's what's called the r-squared value. And as you might suspect, this is the value we get when we square the correlation coefficient. So in particular, these two variables have a negative correlation, right? Because the dots go down as we move to the right. So we would expect the correlation coefficient here to be negative. So to take this r-squared value and use it to find the correlation coefficient, I first need to take the square root of that number. So I can do that with a calculator, but since I'm in Excel, I could type the equal sign to imply that we're going to enter a formula. And the square root function is sqrt. So I'm going to say take the square root of, and now I type in 0.9143. Okay, and that comes from the r-squared value that was over there. I close off my parenthesis, and that tells me that the correlation coefficient in this case is going to be negative 0.95619 if we round that off over there. So it should be a negative value. So the correlation coefficient R is going to equal negative 0.95619. I can highlight that in yellow. Okay, so when you get the r-squared value, don't forget you need to first take the square root of it and possibly adjust the sign. If we had a scatter plot that had a positive correlation where the dots were generally going up, then of course we wouldn't want to make that negative, and we would just need to take the square root. So whether or not you need to adjust the sign depends on whether or not the scatter plot has a negative correlation, like in this case, or a positive correlation. And that's it.